Hello, my name is Michael Walker, and today I'll be presenting the design of a mixed reality cyber-physical control room for lunar exploration. I'd like to quickly thank my PIs, Jack Burns and Dan Safer, as well as the Sea Boulder Nest Group, which is spearheading this project. I want to touch on some human-centered challenges often found in space robots, where robots are working alongside humans, and some of these challenges include robot intention and knowledge communication. How do I know what a robot will do next? How do I know if a robot even knows what to do next? Or effective robot teleoperation. What commands will achieve my goal? Was my goal achieved? And how do I even know what my robot is doing if it's on the far side of the moon? So I'd like to present quickly a subfield of human-computer interaction, which is VAM-HRI, which is virtual and mixed reality for human-robot interaction. So the VAM portion of this field stands for virtual mixed reality, which often takes the form of virtual headset or virtual reality headsets or augmented reality headsets. And HRI stands for human-robot interaction, which is a field of study dedicated to understanding, designing, and evaluating robotic systems for use by or with humans, whether it's in the classroom, on factories on Earth, or in space stations orbiting the planet. And what does VAM-HRI look like in practice today? Well, it is a nascent design space where virtual design elements can be used to enhance the expressivity of robotic systems, and it can enhance co-located interactions with users, or in our case, remote interactions with users. So first I want to touch on the initial ways that this technology was used to enhance telerobotics, and that was stereo video streaming, where a stereo camera would be mounted on a remote robot, and users could see from that the robot's point of view with an HMD that was receiving a live stream from the camera. And each eye would get its own separate image, so through stereopsis, users could see stereoscopic depth, and this interface became a 3D interface, which had many benefits over 2D interfaces, such as judging distances, finding objects, etc. The list goes on and on. But can we do better? This is a pretty simple way of utilizing this technology, just directly streaming to the user's eyes. And also, through proprioceptive miscues, users often get very sick when directly streaming videos to the HMD. So in the field of VAM-HRI, there's been a few methods that looked at improving this interaction for controlling remote robots. We'll present our own today, which is a CyberPhysical control room, which expands upon two different designs, which I'll go over now. And these designs fall under Augmented Virtuality, which is a virtual backdrop where we have real world information displayed within it. So Augmented Virtuality. The first of which is a virtual control room interface, where the user is placed in a virtual space, and instead of directly streaming the video stream to the user's eyes, the video stream is projected on a virtual wall within the control room. And also within this, we can add a bunch of different features, such as adding a 3D model of the robot, which responds to how the real robot is moving, or adding different ways to control the robot, such as these control spheres on the left that the user can grab and move with motion controllers. And this is a robot ecocentric perspective, where it's essentially a first-person view from the robot's point of view. On the other hand, we have a third-person robot exocentric interface called a CyberPhysical interface, which allows users to step outside from the perspective of the robot and view a 3D reconstruction generated from LiDAR laser scans or dense RGB point clouds. So what we wanted to know was, could we combine this concept of first and third person perspectives into a single interface and perhaps get the best of both worlds found in each design? So today we'll be presenting our CyberPhysical control room, which does just that. Our robot that we used for the testing and the development of our interface is a Boston Dynamics quadruped robot. This robot is highly capable of traversing different terrains that one would find on the moon or even Mars, such as low hazard flat terrain, as we can see here, up to more dynamic hazardous terrains found on the moon, such as craters or rocks and debris that the robot would need to identify and then navigate around. We have many sensors mounted on this robot, such as 5 built-in stereo cameras on the front, sides, and back of the robot. And then our own sensors that we have mounted on the top is an additional stereo camera, LiDAR, Wi-Fi antenna, onboard compute, and RTK GPS for localization. This is another look at the sensors that we have mounted on our robot for sending information back to our VAM interface. This is the design of our CyberPhysical control room itself. We use an Oculus Quest 2 HMD. We have live 3D video streams for that egocentric first-person view and 3D reconstructions for that exocentric view. The robot is rendered in the center of the interface, as well as teleoperation commands can be sent from within the interface with controllers and waypoints placed on the 3D reconstruction. Here's a video of an interface working. In this portion here, we can see data streamed from the robot in real time over a wireless network. At the bottom, we have our stereo video stream, and at the top, our 3D reconstruction, which are synced up. This information is sent from the robot operating system to the Unity game engine, which is running our interface. Our 3D video stream has a left and right stream, one for each eye to get that 3D view. The robot is contextually rendered within the interface with its pose and orientation rendered live, so the user can know what the robot is doing in this remote environment. Here we can see both views working in tandem. The third-person exocentric view, which is a LiDAR laser scan, and the top is our 3D video stream, all of which the user can see to better navigate this robot and have improved situational awareness for controlling and monitoring this remote robot. An additional feature that we found useful for this interface below is a user using an HMD to move around the scene and look at the 3D construction for different views. What we have here is, you can see at the top, the video stream is going to move relative to the user's gaze. So if the user takes a different vantage point to look at the reconstruction, the video will then move in front of the user, so all they have to do is look up to see that video stream from the robot's point of view. We intend to evaluate our interface in an upcoming experiment and plan future work where we will compare a traditional 2D interface with our own CyberPhysical control room in a navigation and search task experiment with objective measures such as efficiency and teleoperation errors, and subjective measures which include usability and situation awareness, mental load, and confidence. We'll also look at adding dense point clouds which have RGB points instead of the laser scan that we had from our LiDAR. This will hopefully allow users to get a better sense of the remote environment that the robot is operating within. And finally, I want to provide some conclusions and takeaways for everyone. One is that the research in the field of VAM HRI is a valuable information source for improving the teleoperation and supervision of lunar robots. Our research aims to justify future lunar missions that include virtual mixed reality hardware and improved communication infrastructure for robot sensor data streaming. And finally, mixed reality interfaces will allow scientists to better leverage the capabilities of lunar robots and learn more about the moon. Thank you very much for having me, and I'd be happy to take questions. Thanks.